Hello and welcome. Hello, Star Song. Hello, Paranor. Um, I I always find it so weird saying hello on these things because I'm here all by myself, talking to a screen, um, and then you say hi in the chat, and all is well. And I know I'm not alone on the internet. Can you be alone on the internet? It sure feels that way sometimes. Um, so I am back once again working on my crater impacting simulator. And last we had this story, I had broken it horribly and wasn't entirely sure how I broke it and all the places that I broke it, but it was working well enough, and so I ran away. So tonight we're going to try and figure out how to fix it. And yes, Paranor, that's a really good way of phrasing it. You can be as alone on the internet as you can in a room full of people. And we've all, I think, felt very alone, especially at middle school dances in both of those situations. So welcome. It's true. If I was in a room of acoustic tiles, it would be far worse. So I at least have my fish. So there's fish here, and I have a turtle up there that you can't see. Let me see if I can make it so you can at least see that there's a turtle tank. So there's a turtle that lives up there. His name is Picasso because he's very much not a Ninja Turtle. So, and Paranor, that's about the funniest reason to go to prom I've ever heard. But a valid one. So welcome everyone. For those of you who are new, don't know what you've stumbled into, my name is Dr. Pamela Gay. I am the director of CosmoQuest. This channel that you're seeing is just the tip of a iceberg of science and astronomy, which is a kind of science, the tip of an iceberg of STEM content: science, technology, engineering, and math. We are a NASA-funded project that invites you to help us on a variety of different projects to help us advance our understanding of this universe. We do a variety of different things with this channel. One of them is I'm live coding various simulations and other things that I'm working on that will help people better learn science. And along the way, I'm hopefully teaching you a little bit of the technology alongside the science. I'm not the only streamer on this channel. Along with me, we also have Matt Richardson, who's a PhD high-energy astrophysicist, and he is working on a whole bunch of different stuff and comes on, answers your questions, explains some cool and interesting problems. We also have Joe Meyer. He is one of our programmers. He's Big J if you see him here. And he comes on and does coding of software to help do image reduction that will eventually allow us to be doing, I just realized I didn't send my Twitter, and that's why there's fewer viewers tonight. Okay, I'm sending my Twitter. Big J comes on and he helps people understand how to do digital imaging. So there's a bunch of us that come on here, all of us doing a variety of different science, technology, engineering, and math activities. And you are invited to join us for all of it. Your subscriptions on this channel actually go to helping us, fund science. So on days like when the government shut down, knowing you're here warms my little heart. But anyways, so last week, as I was saying, I left us with barely functioning software. So I'm going to switch over to my programming screen. Oh, that was not what I meant. Let's try that again. That's the screen I meant. Okay. So this is the software, and I'm going to run the code, and the goal of the code is to allow you to see the differences in how a planetary surface will look at a variety of different ages, to see why counting craters actually matters. So I'm going to run this. It's going to drop the window where you can't see it, so I'm going to move it over. So there's my first timestamp. Now it's doing the second timestamp. It's doing the third timestamp. I'm going to click the wrong button apparently. I need to make this smaller to fit on your screen. So what should be happening is, in general, the craters get a little bit darker over time as they age. You can sort of see that happening. But the weird thing, the time is actually the number of frames. I haven't adjusted this to be scaled to the actual universe yet. Right now, I'm just trying to get the code to run. So, yeah, there's something really wrong with this. So the first thing that I'm going to do is I'm going to comment out everything except for our t equals 50, which is just, it's running for 50 frames. And I'm going to get that one to work. And once that one works, I'll bring the others back one at a time. So, okay, we have coming down here, the way the code is set up is first it's just declaring a variety of different variables. So X and Y are the positions that I'm randomly determining for where the craters come in. X, Y, and R are I'm creating arrays that I'm going to store that information in so that I can refresh the craters each frame and change their color. I know that I'm periodically going to want to keep track of the count of the number of frames that this has been going for. I ever so unoriginally named that I, which I'm probably going to hate myself for later, but hey, I at least commented why I did that. And then for other random loops, I'm using J and K, because why not? Part of programming is sarcasm. It's also coffee. I have coffee and sarcasm in ample amounts this evening. So what I'm trying to keep track of here is each of the durations. So this 50 that's one duration, and then I have the intervals, which is how long each of these things goes for. So I'm going to start with an interval of 0. Then I'm going to set it to each of my numbers after this. I'm also starting with the default color for the craters of 55. I think I later stopped using that, so I'm going to actually, well, no, that's where I'm declaring a variable, so I'm not going to delete that. Okay, so the first thing I want to do as I go through and edit my text, I'm going to bump things in so that I know what I've looked at and what I haven't. So the first thing I'm going to edit is I'm going to make this a lot smaller so that hopefully you can see all of it at once. So let me replay this so that hopefully you can see it all. Yay! You can more or less see it all. Okay, I'm going to call that one good. Move this over here and it'll do its thing. Manhattans, only one Manhattan is useful for programming. After one bill, the programming isn't as good as you might want. Paranor, you're totally right. Pizza also powers programming, but I'm finding Thai food and Indian food also work as good substitutions. I think our office is powered by Jimmy John's, the local Thai fusion place, the occasional Indian that unfortunately someone has to drive to go get, and pizza. Those are our 4 things of choice. Okay, so going back to the code. A good curry does wonders for everything, Paranor. You are entirely right. Okay, so I currently have a frame rate of 10. That's how many frames per second it has. I'm now going to set up what are the max number of craters I have, and each crater has a X position, a Y position, and a radius. I could probably do this as a multi-dimensional array. Right now I'm going for readability. So the first thing that I'm going to do is I'm going to put into an array all of the durations. This is essentially how many frames is in each of the quadrants 0 through 3. So the first thing I'm noticing, and this I don't have to comment out yet because all this does is set the intervals. So I have 4 different intervals Why do I have 4 durations and 4 intervals? Hold on, gonna be confused for a moment. Did something weird. So in the last one of these, I told all of you that comments are a way of showing that we love our future selves. So I apparently didn't love my future self enough, or these comments would make more sense. So I know that I have 4 intervals. So I have a for loop that allows me to go through each of them. The first interval is 50 times I plus 1. So it's just 50. That's correct. The next one is going to be plus equal. So somewhere did I set interval to 0? I hope I said, yes, there I set interval to 0. So the second interval is going to be this times 2. I'm going to plus add that so it keeps going and then does the next one. So all of that is fine. And I have no clue. Oh, this is just a check variable. Okay. This is just used to check things. Okay, so I just created that so I could output out the length of each of those. Okay, so that's fine. This line, yeah, so this is just me counting things. Okay. So I put out a new line and now I'm ready to start frames. Almost. I decided I needed a font. So I'm loading the font. The font must be located in the Sketches data directory. Clearly that is the case or this wouldn't work. Okay. So I have a font. And that shouldn't be indented. So this just sets up all the parameters for everything beneath it. Now is where I start to get into drawing all of these different things. Bill Gwen, I see that you're encouraging barbecue while programming, and I'm going to nope that one because my keyboard is already pretty gross, and I don't want to think about what barbecue would do to my keyboard. Okay, going back to this. So the very first frame it draws, so I is equal to 0. It's going to draw my lines. So those are my 4 coordinates. Only takes 2 lines to do that. So I have a line going, this is going from top to bottom. No, sorry. This is going from left from x equals 0 to the full width. So this is the x line. This is the y line. And I'd set it to have a heavy weight. And then I set the weight back to something more reasonable. I then go through and label all of those. So I'm good with all of that. Now the next thing I'm going to do is make my screen wider because clearly I was typing more last time. Okay, so I'm getting a random distribution with a mean of 0 and a standard deviation of 1. So this is telling me that the majority of my values will be 0, but then they go out to plus or minus 1. So I can fold that in half if I want to have values that are only on one side. I can change the spread of this. So what I ended up doing to get the radius is I wanted the majority of these to have little tiny radiuses. So if my maximum value is 0, then the majority of the values in my Gaussian bell curve distribution are going to be close to 0. So they're mostly going to be really tiny craters. I'm taking the absolute value of that because the Gaussian is symmetric about 0. And then I'm multiplying it by a factor that will make it go to more than 1. So I'm spreading it out by a factor of 3. I don't remember what val is. Let me come up here and look. somewhere I set a variable called val. So a standard deviation of 1 is enough because I'm then multiplying it. The Gaussian function that I'm using defaults to a spread. So this function random Gaussian, it has the default spread of 1. And then I multiply it by a spread of 3. And I'm trying to figure out where I set this value called val. I'm going to look. I'm very confused. Float val. Oh, so take the random Gaussian version, and then I'm squaring it to get it even more spread out. Okay. I'm so confused. What did I do? I did something really stupid with this function. I'm just going to lay that out there and say I did something really stupid with this function. So this, I was apparently taking the cube of the Gaussian, which is a really not normal thing to do. So let's come up here, trying to figure out where things went wrong before. I want a spread of 3. I actually want a much bigger spread than that. So let's do a spread of 30 and rerun this and see what happens. Okay, now I got way too many big craters. I think that's why I squared it before, because if you square small numbers, you get even smaller numbers. Okay. So I'm going to do times val times the spread, and that should work better. $30 may have been a bit big of a number. Let's go smaller. Okay. Let's try 3. Apparently 3 worked before. I have no clue why 3 is working. And now it crashed. Why did you crash? Oh, okay, so 3 is too small. So what I'm learning is cubed was apparently on purpose. And I'll have to think about that distribution later. Okay. I'm almost good with this. This is the throwing random numbers in until you get something that looks like the moon stage of writing this software. So I'm going to try it with 4. So I'm looking to see. Oh, so Bill, the standard deviation isn't the standard deviation of the error. It's just with the Gaussian. I'm trying to get a Gaussian distribution. Let me rephrase this. I'm trying to get an exponential, but also random distribution, randomly ordered distribution of radii on my craters. And so the way I'm doing that is I'm using a random number generator that generates that Gaussian distribution, but it's Gaussian instead of exponential. So I'm getting closer to what I need by cubing a Gaussian, which I need to work out the math to figure out just what sort of craziness I have currently created. But it's looking kind of like what I want. I don't know what you mean, Fenmil. But now I want cake. So yeah. The cake is a lie. Okay, so going back to this, this just sets the lines, this sets the labels, this sets the distribution of radii, and then it goes through and it starts drawing things. Now, I only want to draw the first quadrant, so we're going to get that first quadrant absolutely perfect. Now, currently, it goes through and it calculates X, Y. It had calculated the radius up here. And I'm using this duration to figure out, and this is where things got screwed up last time. I'm not going to delete them yet. So it's setting the X, Y. It had set the R up here. It's throwing those into an array. And then let's simplify this for our first run through. So for our first run through, I know that I'm starting at k equals 0 because I'm starting at the very beginning. And then as long as the current value of what it's doing is less than how many frames have elapsed, keep going. So what I want it to do is go through and draw just the set of craters that are within my current interval over and over and over again, and change their color each time so that when a crater first forms, it's white, and then over time it gets darker and darker and darker. So Bill, yeah, so what you're talking about is error distribution, and I don't care about error. I just want to have more tiny things than big things. And so I'm using the Gaussian shape. So I'm essentially abusing a function. Okay. So this crazy equation here. Hey, sweet Chuck, thanks for the follow. This crazy equation here is going through and saying, I want my current color to be white. Sorry, black. 255 is black. Minus the number of the frame that I'm currently on. So, sorry, 255 is white. Minus the frame I'm currently on. So each frame, it gets a little bit blacker. And I'm going to get rid of this middle portion right now because that was put in specifically to deal with the different intervals, and I don't trust it. So I'm going to get rid of all of the stuff I don't trust right now, and then we'll add it in a little bit at a time once I get everything working. Okay, so this should, every frame, get a little bit blacker. So print crater color. So it's printing the crater color down here. We can see the intervals changing in erratic ways. Why are you changing in erratic ways? Okay. I'm going to set the fill crater color, and then I'm going to draw the crater, and it's going to loop through. So the reason the numbers change is because each loop has a different number of these to loop through. Okay, so that makes sense. Oh, thank you, sweet Chuck. I'll post a correction. I really appreciate that. Dang it, I hate it when I do that. Link correction. Twitch.tv/CosmoQuestX still streaming. Thank you for the correction. Yeah, we're CosmoQuestX. Okay. The X on CosmoQuest is simply because the user CosmoQuest is taken most places. So we got stuck adding an X. Hey, Susie, welcome. Okay, so Here I draw the crater, and then the next thing I want to do is our craters have shading on them to make them look like craters. So there's a dark part and then there's a bright part to the shading. And it's based on a percentage of the radius. And the bright part is a fraction of the color. So let me make sure that the color is correct. Nope, it's not. So this should be crater color. Whoa, typos. Crater color plus 50. So that should work a little bit better. It's also a percentage set, and then I just outline it. Okay. So in theory, what this will do now is go through and just keep drawing that first quadrant until everything is black. So let's see if that works. Okay, so it's drawing the first quadrant, and you can see the colors changing, maybe? No. Now everything is stuck in one place. Okay, I broke it. I broke it in a fascinating and useless way. Okay, let's try again. So I am, for I less than dir 0, keep drawing. For k equals, I'm going to add an if statement above this so that this only runs for the first quadrant. So first quadrant is this characteristic. So let me see if that will get this only working for that first quadrant. Because I want to sort that first quadrant. So the 50 constants, that's just the number of frames that I'm giving for each quadrant. So the first quadrant goes for a certain multiple of 50 frames. The next one goes for a different multiple of 50. So 50 for the first set, then the next interval, which is a new interval of time, would go for 100, and so on. So this is my random cratering for a short period of time that occurred for just this quadrant. And that's not bad. I'm kind of okay with that. Now, what I can't tell is if things are actually getting darker over those 50 frames. So I'm going to take a look down here at where I'm adjusting the color. So instead of adjusting it by just one step each time, because my eyeballs may not be telling the difference between 255 and 205, I'm going to say K times 5 just for this time to see if that gives me something that I can see changing. So these should be getting grayer and grayer each frame. And so what it's doing is it's actually drawing the new ones grayer and grayer each frame, which wasn't what I meant. So let me look at my code and see what I just did that I shouldn't have. So the first time it draws a crater, it should draw them. So the first time it draws a crater, it should draw it in white. And then each time after that, it should draw it a little bit darker. So if the crater has a radius of greater than 4, then draw the crater. And and the older craters should be the whitest, and the newest, okay, so I have this, do I have this backwards? Sorry, I hit page down by accident, didn't mean to do that. I'm going to verify what color 255 is, because clearly I can't remember what color 255 is. 255 is white. I'm going to make a comment about that, because comments are how you show you love your future self. 255 equals white. Okay, so the first time it draws something is going to be your oldest K values. So as K goes up, I want things, I'm trying to figure out how to explain this. So this is stepping through and it's redrawing all of my craters each time. So crater R, K equals 0 is the oldest and should always be the darkest. And it's going to cycle through up until the K value is the current frame. Yes, I did type that wrong. Thank you. Good catch. Thank you, FedMill. So what I want is for the smallest K value, which I can get from I. So I have I is my current number of frames. K is my oldest. So I want when I equals K, that's going to be 0, and that's the newest one, and the color should be white. If it's an older one, then I is going to be a bigger number than K, and so like for frame 0, K equals 0, and I is whatever frame I'm on. So let's try this. So things should be getting darker and darker and darker. I think they are. We're now back to the hard to tell shades of gray. So I'm going to rerun this. Yay! Things are getting darker. Things got darker. Okay, progress has been made. Things got dark a little bit faster than I liked, but I now know how to fix that. I just make that a 2. So let's do that. And you can see things getting darker. And that's fine. I can be finicky with it. I'm going to be finicky for one more step and change it to a 3 and see if it's aesthetically more pleasing. And I'm sure I'll fuss with those numbers some more later. Every time I play it, it looks slightly different just because I'm using a random number generator. And some of them look really boring, but so do some parts of the moon. So I'm good with that. Okay, so we now have our shortest time interval working. So now to see if I can get the t equals 100 to work. Now this is where things start to get tricky, where I only want to do the things that are in a given interval. So my first interval goes from 0 to 50. So up here, I scrolled too far. So up here, I can say my current duration. Wow, can't type. My current duration is going to be equal to, so this d of 0 is 50. So I'm going to do dir of 0. That's its max value. So, and it started at 0. So coming down here and looking at my K, where do I start drawing? So for this one, I want to start at my previous duration value. So prev dir. So that's where I start. So now when I run this in theory, it will only do like it's been doing for the past few minutes. Okay, we see things fading, and it's stopped at about the right place. So far, so good. So now I want to add this second duration. So I'm going to come up here, and I'm going to delete those 2 lines because I know that's where my mistake was. I'm not even going to look at the mistakes. I'm going to get rid of my commenting. And then I'm going to say, okay, so with this one, I want to reset what my previous dir was. So previous duration equals the dir 1. Is that right? No, sorry. I'm writing these in the wrong order. Show things in the same order each time or you will like confuse yourself like I just did. So my current duration goes to dir equals 1. And it started at dir equals 0. So in theory, it will now draw the second interval after it stops drawing the first interval. Hey, Keeper of Maps, welcome. IK Raider, what would you want me to I'm not quite understanding what you want to do. I can modulo anything. The question is why. You may be seeing something I'm not seeing. Okay, so and these intervals are each different lengths. So this one goes from 0 to 50. This one goes from 51 to 150 in frame steps because it has a length, it lasts for a length of time of 100. And it never went to the next interval, so I did something wrong. Okay, so I told it to do this. So here I have K. Oh, so let's let it go up to the duration equals 1 here. I see what you're saying. Let's see if I need to do that. I think I can avoid needing to do that. Okay, so these are no longer changing colors. These are still changing colors. And this clearly went longer because I got black things. So my initial instinct to have no multiplication on this, I'm going to go back to that so that I can see colors changing. So apparently if something's really young, you can't differentiate between the craters very much. That's cool. So now I'm going to run this longer. I'm going to see if the craters get noticeably darker. Whoa. Okay, that one ate my crater, so it's harder to tell. So when it goes longer, you can see you have a higher probability of getting big things. That's true. You can see things got darker. So let's see what happens when I do the next two. Okay, so I'm going to do this to 2. I'm going to come up here, and this time I'm going to identify the mistake I made last time and just fix it. So last time I just foobarred my intervals. So this one should be 1. This one should be 2, 0, 0, 1, 2, 0, 1, 0. Okay. So let's see if this works. So doing the first one, doing the second one. Oh, I got 2 craters on top of each other. That's improbable, but happens. This is processing.org. It's basically a bastardized version of Java. It's super easy to do visualizations in, unlike R. And what's nice is you can compile them out and stick them on websites or turn them into animated GIFs or GIFs. I don't care how you want to pronounce the word. Okay, so we now have T. We have now that interval working right. So now I'm going to go ahead and kill off that. See if that works. I'm going to get rid of the if statement I added just for error checking. Press play. And this is the does it work part of just hoping it works. I love how you're all arguing over this. So the age of the craters is actually just their array number Icarus factor. The ones that appear darkest on the screen are the oldest in any given area. And then the regions, when you see more craters, that's an older region. So if this goes well, I'll pull up a thing of the moon in a moment and we can compare. So I'm actually kind of pleased with how this turned out. So here is our simulated area of the moon. I'm still not totally pleased with my distribution of craters, but let me pull up a piece of the moon, and I'm gonna get LRO data, except I typed LCO, which was wrong. I'm gonna get LRO data, which is the Lunar Reconnaissance Orbiter data to use. So this is the actual moon. I apparently found an animated GIF, however you want to say it, of a new crater forming on the moon. That's wild. I just grabbed an image off the internet. So you can see right here a brand new white crater forming, splattering black stuff everywhere. So you can actually see that with real craters, the white ones are the newer ones. You can look at this, you can see some of the surface has returned to being the same color as everything else. And you can see the random distribution with not that many big ones, a whole bunch of little tiny ones. So this is our actual moon. Yeah, these are not timestamps. T is relative ages at this point. So after the simulation has run, this is an area of the moon that was swept clear of craters at an interval of unknown units 50 ago. This is an older area. You start to see darker craters, you see more craters. It's 100 units of time ago. This one is even more craters. It's 150 units old. This is 200 units old, and it's even older. So you see even more craters. And this is how the actual moon has ages of different parts measured. It's by looking at This part of the moon has a ton of craters. This part of the moon is bare of craters. And if there's no craters somewhere, that means that something swept that area clean. It either was impacted by something that erased that section. It was filled in with lava. Something happened. And when we look at Pluto, and let me pull up a picture of Pluto. When we look at Pluto, we know that it's young on the surface for the most part because it doesn't have that many craters. There's a rocket launch. Wait. Oh, someone followed. Hello. I'm going to say that I have no clue how to say your name. It looks like Fshku or Fshkai. I don't know. Phonetic spelling. Phonetic would be awesome. Welcome. I don't know how to say your name. Welcome. I get sad when I don't know how to say people's names. Okay, we have Pluto. Here's Pluto. There we go. Pluto. So you can see that some areas of Pluto have craters. These areas that have craters, these are a whole lot older. This area here, Sputnik Platinum, this is something that the ice here is less than 50,000 years old. The ice here is younger than the amount of times that bumblebees have been in the Earth's honeybees at all have been in the Earth's fossil record. So we're able to look at Pluto and say, this is young. It has no craters. It's a world. We're going to go with the word world because we can all say this is a world, Titan is a world, all the round stuff, those are worlds. So this is a gorgeous world. It has cracks. It has some craters, but not that many. And you can get at these mountains up here. These are fairly young. This is entirely young. There's nothing here. This over here is much older, much more shredded. And so looking at this, we can get at the relative ages. We can't get at the absolute ages other than to say probability is that if this was older than 50,000 years, it should have craters. We don't see craters. It's younger than 50,000. We don't know how much younger. For all we know, this formed in our lifetime. Probably not. We just don't know. So here we are. We can see relative ages just like we can with our simulation, where this is young, this is a little older, and this is a lot older. So does this make sense for relative ages? Did I successfully make a pretty boring looking simulation that if I make it a whole lot bigger might actually make sense? Icarus factor, we don't know what's at the core of Pluto. One of the cool things about this is since it clearly has some sort of tectonics, since the surface is somehow getting changed over time due to internal processes, it must be warm inside. So that means it probably has either a lot of radioactive materials inside that are keeping it warm, or it went through a not too far in the past significant collision that remelted it. It's got rock in it. We know that. But we don't know for sure. It's not the iron cores that make worlds spin. Having a magnetic core helps generate magnetic fields, but you can do it just by having something that's hot with a bunch of ionized particles. It's just metals have so many extra electrons. They're much easier to get charge freed from. So yeah, we have worlds with all different compositions. We have worlds that are rocky and molten and have tectonics and are covered in ice like this, like the moon Europa, like the moon Enceladus. And it's not just Pluto where we see this youth. Let me bring up a picture of Europa. Europa. Oh, except I apparently spelled Europe instead due to autocorrect. Okay, there we go. This is the one I want. So here we have Europa, which has a frozen icy surface, and you don't really see craters here. And this frozen icy surface does have some defects, but for the most part, it's just ice that's cracked with red material rising up from inside. This has been like colors stretched within an inch of their photons. But there's darker more materials that are coming up through these cracks in the ice. And the surface is clearly getting regularly refreshed. It's cool. It's a changing world. So Fenmil, I don't actually know about nitrogen tectonics. I just know that we're pretty sure that Pluto's warm inside, and I'm going to hold it at that. Yes, Europa has tholins. Tholins is a new word for me. I learned that one from Planet Doctor Sarah Horst. I have to admit to being a stellar astronomer and a programmer, so I'm learning planetary astronomy too. So this is what I wanted to work on tonight. What questions do you guys have that I can answer? I'm just happy that I got my simulation doing things. Why are you being so sad? Just no one other than you have a sad username. Pluto's still loved, even if we did only fly past it and not stay there. But seriously, what questions do you guys have that I might be able to answer? The next simulation that I'm going to be working on is I'm going to be working on, I'm not going to get into the planet argument with you guys. It's a world. We're going to go with world. The next simulation that I'm going to be working on is one of variable stars, which is like where my heart is, to show you how they change in size and color. And I'm going to work on actually getting that one like science lined up and set up. So yeah. I want to try and find an animation I remember of the New Horizons flyby, alone and then not alone. There was this adorable graphic, and I don't know if I'll be able to find it again, of a cartoon. There it is. I found it. It's on YouTube, as most things are. So I think that's just like the saddest ever little graphic. So I just wanted to share it with all of you. Yeah, IK Raider, craters are almost always round. So what makes the crater's shape isn't the angle of attack, like when a baseball hits out in a field or something. So you have and I actually have a little meteorite on my desk. You have your asteroid, which becomes a meteorite after it's crashed onto a surface. You have your space rock coming down, and when it hits, a great deal of its mass, all of its velocity goes and gets converted into a shock wave. And that shock wave moving out from the point of impact moves out in a sphere. So it's the energy of impact getting dispersed in a sphere that leads to the round crater. Now, one of the weirdo exceptions within our solar system is when we look at Vesta, which you can do in CosmoQuest Vesta Mappers project. A lot of those craters are ovals, and the reason for this is Vesta used to be rounder than it is now. And at some point in its history, something hit it really hard and squished it. And it has wrinkle ridges around its middle, and its rotational axis, the pole that it rotates around, actually got changed so that the crater of whatever hit it so hard is now the south pole of Vesta. So yeah, Vesta has a whole bunch of oval craters because they used to be round and then Vesta got squished. So yeah, it's the energy and not the impact itself that makes the shape of the crater. I need to move. Yes, I can move into my big frame. Thank you, Gordon. Okay. So, other questions? Could you explain orbital resonance? I have heard the term, but not good explanation of it. Yes. Okay. So, oh God, I need 3 hands. Okay, I'm going to use my microphone as a planet. We're going to pretend my microphone is Jupiter. And here is baby planet 1. Here is, I'll get 2 baby planets that are very different colors. Here's baby planet 2. Moons, they're moons. So here is large world, here are my 2 moons. With an orbital resonance, I have this one is happily going around. And now here I get to prove how uncoordinated I am. So this one goes around, and then when this one completes its orbit, this one is down here. So this one has gone around once, this one has gone around half. Now I'm working on getting back around, and they both end up here at the exact same time. So for every 2 times the inner one goes around, the outer one goes around once. So I'm going to try to repeat what I'm doing. I need another hand. So here we are, end of the first orbit. Here we are, end of the second orbit. And when everything is lined up like this, there's a lot of extra pull on this world. So this world is now getting pulled on by this moon and by the planet. So it's getting stretched. So every time these 2 are together, this one gets more stretched. This one is also now getting pulled in 2 different directions. So it's getting a different gravitational pull here. And then when they're like this, it's getting more gravitational pull because now it has this moon up here and the planet up here. So every time you have them in a line, one of them is getting extra pull on it and is getting extra stretch. And the inner one goes around faster. So the reason that this happens is partially just random bad luck. Another part of it is when things first come in, they might have a very elliptical is the correct word. They might have a very elliptical orbit, but because there's multiple moons, all on different elliptical orbits, over time, all of their different gravitational tugs are going to interact with one another. And with a bunch of different moons, all of these interactions over time average out to put things in circular orbits. And because these 2 things are going to attract each other, they're going to, as this one comes up, it's going to slow this one down to try and lock them up. As this one tries to pull away, this one's going to pull it back. And that tends to sink things into a resonance. So they start out with completely random orbits, and then over time, things get pulled into these resonances. I do need an orrery keeper of maps. It's true. So the forces that our two moons are feeling when they're all lined up, these are called tidal forces. And there's actually tidal forces on our planet as well. Sorry for tapping on my mic. I wasn't thinking. So anytime you have an object that has an external mass pulling on it that is trying to pull on the nearer side and pulling less on the far side, this external force is a tidal force. So our Earth's moon exerts a tidal force on the Earth, which causes the tides, because astronomers are super boring when we name things. The forces between the different moons and the different planets are all called tidal forces. It's just this external body is creating a force on the moon. Sorry. Okay, looking quickly at what Fenmel said. We do need more laser sharks. A dark matter projector would be super boring. Aliens, depends on the alien. So that's what I had planned for tonight. And I'm going to say thank you for joining me. And I will be back here at the same bat time, same bat channel next Tuesday night. I will consider, after I do variable stars, doing a simulation if I can figure out how to show how microlensing works. That one's a lot harder, but we can work towards it. So yeah, we got this code working. Let me give it one more run before I call it a night. And I will be blogging about this hopefully pretty soon up on CosmoQuest. And we have something that hopefully helps you understand how we count craters. So thank you all for joining me. And next time someone's going to be on this channel is tomorrow at noon Central, 1 Eastern. That is 8 a.m. Pacific. Sorry, West Coasters. And if you're in Europe, it should be a perfect time for you. Microlensing is a little bit more complicated than that keeper of maps, but we'll get there. So have a great morning, evening, or afternoon, wherever you are. It's been a great evening. I'll talk to you all later. Bye-bye.